So, what was I talking about? Anyways, yeah, it ends up, but something changes. What if I add a negative to the front term? Okay, they're all upside down. So, like, instead of going from down to up, it goes from up to down. From up to down. From up to down. And instead of going from up to up, if I put a negative on the front of these, guess what? It goes down to down. More like an M, not a W. More like, I don't know. Yeah, I forgot we did this, but now I kind of remember. All right. You guys got the pattern? We will be graphing these basically by looking at the powers and by figuring out where it crosses the x-axis at. Kind of those two things together will help us figure it out. So those probably would have been good notes to take, or you guys have memorized. It's kind of in your book on page 64 at the bottom.
Are you gonna do math with us?
I'm gonna do the odds with you.
Oh,
All right. To the graph paper. To the Batmobile. Come on.
Yeah, I'm 26%
The world is
Mr. Jordan, have you ever shed tears while doing math? Have you ever like cried while doing math? It's like too hard.
Olivia?
I've cried from joy. Math makes me emotional. But tears of joy.
No, it's not. No, it's not today. I know it's not today. I said, you didn't.
Oh, all right.
Yeah.
Okay. No. Vetoed.
You're not gonna zoom in?
Zoom in.
You always zoom in.
Not on the graph paper. All right, so on number 1, x plus 1, x minus 2, x minus 4, we are not going to multiply these together. But if we did multiply it together, what would it create? X cubed. Because eventually all three of these x's would be multiplied together, and the largest power would be a third power. So it's a cubic function. What shape does a cubic function take?
Down.
Yeah, squiggle. Also, I'm noticing it's going to be a positive cubic function because it's positive x times positive x times positive x. So it's going to go down to up. If one of these x's was negative, that would make it the whole thing negative and it would flip upside down. Okay, this is easy peasy, no problem. All right, what we need is the zeros of the function. What x values make this function, or they're also called the roots, what x values make this function equal 0? Negative 1. Right. So when you plug in negative 1, the y value is 0. So that means there's a point at negative 1, 0. When you plug in 2, all this equals 0. When you plug in negative 4, all this equals 0. So those are the zeros of the function. They're also called the x, they're also the x-intercepts. So it's going to cross at negative 1, 2, and negative 4. All right, and then how am I going to graph it? Well, I know the shape is this, so I'm just gonna kind of
So it doesn't matter
fill it in.
where your hoop goes.
No, usually it's a little too much work to try to find every little point, so we just are gonna do that. There is one trick that can help you be more accurate. Do you know how to find where it crosses the y-axis? I put it about -2, but do you guys know how we can tell for sure? What is the x coordinate for this point right here? 0. So the y-intercept always has an x-coordinate of 0. Now you could do any point, like you could plug in x is 1, x is -2, -3, and find where these are. But the y-intercept is a common point to plug in. 0 is pretty easy to plug in. If you plug in 0, this would be 0 plus 1, 1, -2, 4. 4 times -2 times 1 is -8. So really it should be all the way down. Here's what it would really look like. 3, 4, 5, 6, 7, 8, -8. So that would make it really steep. So that's more accurate. Am I going to be that picky? No. Actually, I think the one on the test I does ask for the y-intercept. If I remember right. I kind of missed that spot.
Can you get rid of that?
I'm going to just drop it. All you do is plug in 0 for the x value to find the y-intercept. You don't want to?
How'd you do that?
You're the only one talking. Alright, number 3. Okay, if we multiplied all that together, what kind of function would it be? X times x times x? Cubic function. What's different about number 3 though? It's a negative. There's one of the x's negative, which would make the whole thing negative. So it's going to look more like this. The directions? No, okay. Oops, I don't know why I did that. Okay, so what are the zeros of the function? What are the x-intercepts? -5, -3, and 0. So kind of everything is happening to the left here. So -3, -5, 0. Those are the x values that if you plug them in, would make the whole thing 0. Okay, and then I'm just following this pattern. I wonder if I could like blow it up and make it fit right. No.
Looks amazing.
Thank you.
Dang, I drew it the wrong one.
1.5, 3.5.
Right, give us 36.
-1.5.
Good.
All right. Okay. 5. Still moving, still rocking. Okay, x squared times x. So that is another cubic function. Is that one going to be positive or negative? Positive. So it's going to be more like number 1. Okay, what x values? Now this is another important point. What x values would make this equal 0? -2
0.
and 0. Okay, 0 when it's squared it's kind of like it's called a double root. Okay. And it does something different. It still hits the x-axis at 0, but it does something different. So you can tell if it's a double root, kind of if it appears twice. Like if there was an x plus 2, negative 2 would have been a double root. But sometimes it's just written like this. Negative 2 is a double root. On this problem, 0 is a double root. Okay, so what happens at double roots is instead of going through the line, it bounces when it hits the line. So it doesn't actually go through the line. So 0 is my double root. So when I'm approaching 0, it's going to bounce right there and then go back up. So it keeps the same shape, it just does not go through at that point.
That's kind of cool.
No, it's just one.
No. This is not Friday.
Maybe. Okay. Yeah, I guess. Today is Wednesday.
Oh, huh. You're fine.
Wasn't a joke. Okay. Number 7. Alright, if we multiplied all those together on number 7, what would we get with the x's? What would the highest power be? 4. X times x times x times x. Actually though, if you look carefully, one of those x's is a minus x, which means it's a negative x to the 4th. This is called a quartic function. That's not a word that comes up a lot, but it might. Anyway, it just means x to the 4th is power. So what shape did x to the 4th take? W, so negative is m. Rho. Okay, so it's an M shape, so it's going to look something like this. What are the x-intercepts? There. 0. One.
Is 1 like a double thing?
No, these are different. This 1 would make this one 0, right? Which would make everything 0, and negative 1. So 0, 1, negative 1. Not a double root. What was the last one? Negative 2. Negative 2. Alright. So negative 2, negative 1, 0. So no double roots. These points are kind of close to each other. Whoops. So it's not going to get really high. .5. Actually, this one would be really shorter than I drew it. Like barely gets off. Anyway, so it's okay. What number is that? 7? What color do you guys think this is?
Red.
It's an optic illusion.
How?
Oh, hold on.
So red.
This is red.
What's that then? Orange.
It's orange red.
Ah, you were wrong. I don't care.
It makes this one look pinkish, doesn't it? Like
Yeah.
pinkish purple. But this is the shade I normally use.
You're a scammer.
You should use purple.
How'd you find this out?
What do you mean?
You just tricked us.
Chose
What are
it.
you talking about?
This is
Look at,
I
Dad.
hate you.
Go back over. Turn around.
I hate you.
Isa,
Dad.
turn around.
No.
Turn around, Addie.
Display your shame. Okay, number 9. So we got x plus 1 cubed. So this is a cubic root. This is something different. X plus 1 cubed times x minus 2. So x plus 1 cubed means there's like 3 of those multiplied together, right? So there's an x cubed just inside of these 3. And then x minus 2. So what are the 2 roots? -1 and 2. Okay, -1 is a, oh, hold on, I forgot. What shape does it, or what's the degree gonna be? X times x times x times x.
4.
X to the 4th. So what shape is it gonna be? W.
W.
Okay, this is gonna be a janky W, because cubic root, so remember a double root stops at the line and like bounces? A cubic root, it goes like it's going to stop, and then it gets like flat, and then it just keeps going. So that's gonna happen at -1. And then at +2 is a normal root, so it'll just pass through. So it's not really a W on this one, unless it's like a real sloppy W. So at the cubic root, it gets flat, keeps going. If you had a graphing calculator, you could plug this in and see it. Kind of use it to cheat. I was gonna do Friday graphing calculator, but now it might be Monday. I need to get batteries though. Somebody was, I have like 7 or something like that. So somebody said they had one, didn't they? Okay. So we might just have enough then.
My mom.
Well, we got 8. Okay, maybe grab it if she's not using it. All right. I'm not 100% sure they all work, so I think they work, but we'll have to check. I need batteries checked, some of them. Okay. I lost my place. 11?
Yeah.
X squared, x plus 2, x minus 1, x plus 1. Oops. X minus 2, x minus 1, x plus 1. Okay, if we multiplied all these together, what would the degree be? 2, 3, 4, 5. You guys remember what shape a 5 took?
Wait.
This, I kind of think of it as a snake. It's a snake. All right, but 0 is a what?
2.
Double root. It's a double root, which means it's going to bounce at that point right there. So you got to be careful when you draw. So -2, +1, -1. Okay, they're really close to each other, so that means it's going to be really not going to get very high. So I'm going to start down, end up, and I'm going to make sure I bounce when I get to 0. So start down, go up, down, bounce, back up.
Does it always bounce down?
No, if it's on the top, when it bounces, it'll go back up. If it's on the bottom, coming up, it'll bounce down. The other one, it bounced just wherever you're coming from, it's gonna bounce and go back that direction. Okie dokie. 13. These are actually pretty easy to, not much to these. We got to factor 13 through 16 before we do it. So they've, on 1 through 12, they did all the factoring for us. Okay, this is the grant specialty. How do we factor that grant? Oh, there's only one X on that. How do we factor this?
Take out
Take out an X. And then you're left with X squared minus 4, and this factors, right?
yeah, x square minus square.
It's a square minus a square, so you take the square roots X and 2, you do X minus 2, X plus 2.
That's the only math I
Well, when you're gone, other people remember to take stuff out. Like Kate and Anissa.
What?
They remembered to take stuff out. That's the grant specialty. The grant deluxe. It's not working. Okay. So it's just 3 X's, so it'll be a X cubed. So it'll be the squiggle. So -2, 0, 2. Very basic on this one.
It's becoming big.
Uno mas. Alright.
Wait, can you go back?
X to the 4th minus X squared.
Do you think?
Okay, is that it? Yes. Alright. So what can we do on this one? Take out an X squared. So when you divide out an X squared, X to the 4th divided by X squared is X squared. X squared divided by X squared is 1. You can tell you did it right if you multiply it back together and it turns into that. Okay, what can I do with X squared minus 1? It's a square minus a square. Both of these have square roots. The square root of this is X. And the square root of 1 is 1. So you do plus 1 minus. Okay. This is a quartic function, X to the 4th. Therefore, what shape will it take? W. Because it's a positive X to the 4th. This negative doesn't really matter because X to the 4th is the strongest and it kind of dictates what's going to happen. Okay, the roots are 0, -1, and 1, and 0 is a double root. So when it comes to 0, it's actually going to bounce. So it's going to go through normally, bounce, and go through.
Yay.
Kind of.
Oh no. What else do
We
we
finished the odds. That's
Oh, I have one.
too fast or too